Hello everyone, this is Eugene. I'm making this video on a data analysis tutorial for the next batch of capstone students. So let's get started. So with it, let's start with introductions. In this session, we'll be diving into the first half of a complete data analysis workflow, but a very simple one. And the dataset that we'll be using for this exercise will contain daily sales transactions from 5 different stores. I've made it intentionally messy, which would be pretty good for us on how to learn, obviously how to learn how to deal with real world data, which will be very messy in the future. So in this session, we'll be using Python, specifically pandas and matplotlib inside a Jupyter notebook. And hopefully by the end of this part, everyone will know how to clean the dataset, run EDA, and uncover insights that actually mean something. So let's continue and we'll do the problem statement. Let's start by defining the problem. So imagine you're an analyst at a retail chain. Your job is to figure out which stores and product categories are driving revenue and whether there are any patterns in how products sell over time. So our objectives are simple. We'll find the top performing stores and products. We'll then understand the sales trends and prepare the data in a way that support the dashboard and business decisions later on. But before we start, there are actually numerous common data issues within the dataset that we'll be using. And this will reflect real-world issue in the future and in their capstone company. So we have to deal with what's broken in the dataset. So I'll show you later I'll show you the dataset later, but before I'll just say like what's wrong with it first. Our store IDs are formatted in a way that is very inconsistent. Some have uppercase and some have lower cases, and some even have like extra spaces. The unit sold column has a mix of numbers and text like 20 and the number 20 itself and the word 20, which will probably break your calculations. And the revenue itself is actually even worse. There are some entries that are string and some that are in yeah, you know. And the category column has numerous inconsistencies such as like electronics and like uppercase electronic and lowercase electronics. Yeah. So all these should be treated the same, and if we don't like really clean this up, they'll come up as misleading or just like plain wrong. We'll do data wrangling on the dataset later, but first I'll like tell you I'll just like give an outline of what we'll be doing. So we have to start by cleaning the data strings. We'll like take away the white spaces, we'll standardize capitalizations, and convert string numbers like 10 into actual integers. Next, we'll handle missing values, and that might mean like dropping the row itself, or filling them with averages, or flagging them as unknown. It depends on the context. Uh, yeah, but the dates also has to be fixed. We'll convert them into a datetime object so we can actually do time-based analysis later on. And finally, we have to enforce consistent data types across all columns, which means making sure numeric columns are actually numeric and categorical columns are standardized. Once this is done, we'll be then ready to analyze. So the last part of this slide will be talking about EDA, or exploratory data analysis. So after we clean the data, we'll now be ready to explore. We'll start with like univariate analysis. We'll look at the individual columns. How many units are sold? What categories are most common? Then we'll move on to bivariate analysis. For example, we might group the data by store ID and then calculate the total revenue per store. Or we can check whether discounts are helping or hurting revenue. Then we'll look at trends over time. Is revenue increasing, flat, or all over the place? We'll use line charts and bar plots, and this will basically help us review all these patterns. But all in all, the goal of EDA is not just to make your charts ready. It is to build an intuition about what's going on in the business based on data. Alright, this is the end of the slideshow. We'll be moving on to the practical itself, and there I'll show you how to actually do data wrangling and how to uh, dish out visualizations for the EDA. Thank you. Hello, we'll be continuing on from the PowerPoint slides just now. We'll be moving on to the practical portion of this tutorial. So, we always want to start by looking at the raw data, and I'll show it to you later. Not the schema, not column names, but the actual content within the dataset itself, because data quality problems hide in plain sight. So here what we're working with is a retail sales dataset that I've generated from ChatGPT. I just load it in. Yeah, okay. So I've displayed the first 5 rows, and we already spot some issues. We have inconsistent formatting. We have weird string values. We have like strings where numbers should be, and we have like a mix of missing and malformed data. So previewing data helps us build an instinct for the dataset's messiness before we blindly run any code. So next step, we would like to clean the strings up first. So things like store names and product categories. Why we're doing this is because these values are often used for grouping or filtering, and if they're inconsistent, we'll get really misleading results. For example, let's just go back here. We have store 4 and store 2. Do you see them? We have like inconsistent like capitalizations. So imagine if this is actually store 2, it won't actually show up as store 2. So even if you go through the filter, it'll be treated as like a different store unless we fix the formatting. So that kind of mistake can like destroy our analysis. So what we're doing here is to basically strip these of their white spacings. It will fix the casing, and we'll lock the column downs. As you can see, we have now created proper formattings and proper casings. So next would be dates. Dates are one of the most misused data types. It is stored as strings, but they're like meaningless text if you can't sort them out properly. This way, you are unable to extract months or run any like time-based analysis. So what we want to do here is convert the date column into a real datetime object that we can use time intelligently later. We can use them in like trends, seasonality, filtering, and all that depends on the step. So as we can see, our dates, this is not the correct formatting. We'll be changing this to a datetime formatting, which is basically this. And now we can see the trends when we do visualization later. Next, we'll be cleaning the unit sold column. Let's see, unit sold. Alright, you got a bunch of like missing values and stuff. So this is basically critical for both KPIs and any serious modeling later on. So the issue with our unit sold column is that it contains junk values. So it contains like strings where integers should be. So if you try to do any sum or average in that column that is currently in the state, it will like fail or give incorrect output. So what we want to do is we'll force the column to be numeric. Anything that does not fit becomes NaN, and then we'll do with those systematically in a moment here. So revenue in our data set is a key business metric. It drives almost every downstream decision from like pricing, marketing to forecasting. But in our case, we have a polluted data set, and it contains strings like 300 where integers should be. So this is not just a formatting issue, it is kind of like a trust issue. If the revenue isn't clean and numeric, then anything built on it, such as like KPI, dashboards, forecasts, becomes unusable. Or then from this cell, we'll sanitize it, and we'll make it more reliable. Which is basically what we did just now. We're just converting everything that is not a integer to NaN, and then we'll like deal with it later on. So the next one will be how's that? We'll be cleaning the discount columns. So discount influence behavior. Customer respond to price drops. So we need to understand the relationship between discount levels and revenue. But this is only possible if our column is numeric. It's the same as the revenue column. We have strings where integers should be. So let's just go up. Okay, it's not shown here, but in the larger data set, which I will provide later on, it does show. So it's like it's the same issue, 300, where it's supposed to be a number, not a string. So same thing. Run this, and we'll drop everything that is not in integer. And okay, since we now have a bunch of missing values from conversions, we have to fill them up because our data set only has 2,000 rows. Oh wait, sorry. Yeah, wait. Before that, we have to check for missing values. Yeah. So because like missing values itself is like really bad. It's also really informative. So knowing where the gaps are basically will help us like to fix what's wrong, know what to drop, and know what to input. It's kind of like a quality control checkpoint. We just run it here. Yeah, as you can see, a bunch of missing values in the unit sold, revenue, and all that stuff. Okay. Yeah. Before I was like, I was kind of like jumping around. So this is the part where we have to fill in the missing values. In normal cases, especially in like large data sets with like maybe 50,000, 100,000 rows, you can afford to drop rows because there's just so much data to go around. However, for data sets that are like rather small like ours with only like 2,000 rows, dropping any rows would be like pretty bad, We'll then have to fill in the missing values. We cannot afford to discard data in our case because yeah, we just have really little data. So now what we'll be doing is to like fill in the missing data with median. So this basically keeps the distribution relatively stable. It helps avoid extreme biases, and it helps us keep going without introducing any holes in our analysis. But there are other methods of like handling missing values. You have like mean, median, all that stuff. But for our case, we'll just stick with median. And if your data set is large enough, you can just drop the row entirely. Okay, let me just run this. Yeah, okay, so no missing values left. So now everything is clean, and we would like to, let's just preview the new clean data set. Okay. As you can see, everything is like pretty alright. We filled in the missing values, and we changed, yeah, we just changed all the stuff to integers. Okay, let's do the univariate analysis. This is the EDA part. We just run this. This basically what we're doing basically helps look at the transaction volume per store. Are some stores like busier than others? These are the questions we have to ask ourselves. As you can see, yep, we take a quick look at it. There are some stores that are busier. We check the units sold. Is it like mostly small purchases, or is it like bulk orders? This gives us context to what's happening in the business. Now we'll be moving on to the bivariate analysis. We would like to bring the variables together and start making more strategic questions. Which stores generate the most revenue? Which categories are worth investing in? And what patterns emerge when we compare sales to discount or product types? Like these groupings will help us form the backbone for most business dashboards. So we are not just exploring data, we are kind of like simulating the questions a manager will ask. So we'll just run this. Bam. Okay. Yeah, you can see. Pretty insightful for what we'll be what we'll be doing on later. Next would be the time series. Okay, so time series analysis help us see movement. It is not just totals. So we are not just asking how much revenue, we're asking when. So spikes can reveal successful promotions, seasonal patterns, or sudden changes in customer behavior. Without this step, you'll miss really important temporal dynamics that often are very important when it comes to a business. Let's just run this. Yeah, as you can see, around like the end of March, we get a huge spike in revenue. This can be useful later on. We'll we'll dive deeper into that later in our dashboard series. Okay, so all in all, this data set is no longer messy. We can use it in our dashboard, and we now can understand what's selling, where it's selling, and when the revenue is coming in. Yeah, we'll move on later to part 2 where I'll create a dashboard just for you guys.